Phenol formaldehyde resins are synthetic polymers obtained by the reaction of phenol or substituted phenol with formaldehyde. Phenolic resins are mainly used in the production of circuit boards. They are better known however for the production of molded products including pool balls, laboratory countertops, and as coatings and adhesives. In the form of Bakelite, they are the earliest commercial synthetic resin. Formation and structure: phenol formaldehyde resins, as a group, are formed by a step-growth polymerization reaction that can be either acid or base catalyzed. Since formaldehyde exists predominantly in solution as a dynamic equilibrium of methylene glycol oligomers, the concentration of the reactive form of formaldehyde depends on temperature and pH. Phenol reacts with formaldehyde at the autoinpara sites, allowing up to 3 units of formaldehyde to attach to the ring. The initial reaction in all cases involves the formation of a hydroxymethylphenol, HOC6H5 plus CH2O HOC6H4CH2OH. The hydroxymethyl group is capable of reacting with either another free auto or parasite, or with another hydroxymethyl group. The first reaction gives a methylene bridge, and the second forms an ether bridge, HOC6H4CH2OH plus HOC6H5O2CH2 plus H2O. The diphenol 2CH2 is called bisphenol F, which is an important monomer in the production of epoxy resins. Bisphenol F can further link generating tri- and tetra and higher phenol oligomers. 2-HOC6H4CH2OH2O plus H2O, Novolacs. Novolacs are phenol formaldehyde resins with a formaldehyde to phenol molar ratio of less than 1. The polymerization is brought to completion using acid catalysis such as oxalic acid, hydrochloric acid or sulfonate acids. The phenol units are mainly linked by methylene and or ether groups. Novolacs are commonly used as photoresists. See also photolithography. The molecular weights are in the low thousands, corresponding to about 10 Euro-20 phenol units. Hexamethylenetetramine or hexamine is a hardener added to cross-link novolac. At a temperature greater than 90 degrees Celsius, it forms methylene and dimethylene amino bridges. Resols, base-catalyzed phenol formaldehyde resins are made with a formaldehyde to phenol ratio of greater than 1. These resins are called resols. Phenol, formaldehyde, water and catalyst are mixed in the desired amount, depending on the resin to be formed, and are then heated. The first part of the reaction, at around 70 degrees Celsius, forms a thick reddish-brown tacky material, which is rich in hydroxymethyl and benzylic ether groups. The rate of the base-catalyzed reaction initially increases with pH, and reaches a maximum at about pH equals 10. The reactive species is the phenoxide anion formed by deprotonation of phenol. The negative charge is delocalized over the aromatic ring, activating sites 2, 4 and 6, which then react with the formaldehyde. Being thermosets, hydroxymethyl phenols will cross-link on heating to around 120 degrees Celsius to form methylene and methyl ether bridges through the elimination of water molecules. At this point the resin is a three-dimensional network, which is typical of polymerized phenolic resins. The high cross-linking gives this type of phenolic resin its hardness, good thermal stability, and chemical imperviousness. Resols are referred to as one-step resins as they cure without a cross-linker, unlike Novolacs, a two-step resin. Resols are major polymeric resin materials widely used for gluing and bonding building materials. Exterior plywood, oriented strand boards, engineered laminated composite lumber are typical applications. Cross-linking and the phenol-formaldehyde ratio. When the molar ratio of formaldehyde, phenol reaches 1, in theory every phenol is linked together via methylene bridges, generating one single molecule, and the system is entirely cross-linked. This is why Novolacs do not harden without the addition of a cross-linking agent, and why resols with the formula F, P greater than 1 will. Applications: phenolic resins are found in myriad industrial products. Phenolic laminates are made by impregnating one or more layers of a base material such as paper, fiberglass or cotton with phenolic resin and laminating the resin-saturated base material under heat and pressure. The resin fully polymerizes during this process. The base material choice depends on the intended application of the finished product. Paper phenolics are used in manufacturing electrical components such as punch-through boards and household laminates. Glass phenolics are particularly well suited for use in the high-speed bearing market. Phenolic micro-balloons are used for density control. Snooker balls as well as balls from many table-based ball games are also made from phenol formaldehyde resin. The binding agent in normal brake pads, brake shoes and clutch discs are phenolic resin. Synthetic resin bonded paper, made from phenolic resin and paper, is used to make countertops. Phenolic resins are also used for making exterior plywood commonly known as WBP plywood because phenolic resins have no melting point but only a decomposing point in the temperature zone of 220 degrees Celsius and above. Phenolic resin is used as a binder in loudspeaker driver suspension components which are made of cloth. Sometimes people select phenolic resin parts because their coefficient of thermal expansion closely matches that of the aluminum used for other parts of a system, as in early computer systems and Duramold. The Dutch forger Han van Meegeren mixed phenol formaldehyde with his oil paints before baking the finished canvas in order to fake the drying out of the paint over the centuries. Trade names: Maritex Aquarius is a very high-performance bearing material made using Novolac resin, fiber reinforcement and added lubricants for momentary dry run situations. It is also used dry at slow speeds and high pressures, showing very low wear rates of shaft or bearing. Bakelite is made from phenolic resin in wood flour. Novotext is cotton fiber reinforced phenolic, using randomly oriented fibers. Oasis is an open-cell phenolic foam that readily absorbs water and is used as a base for flower arrangements. Biodegradation: phenol formaldehyde is degraded by the white rot fungus Phenowuchalate chrysosporium, see also, urea formaldehyde, references. External links, no longer available from the previously linked source.